The goal, I always remember that gain is not a volume control. It is the front door to your mixer. The goal is to use gain to get everything operating at the same level before it comes into the mixer. And this may seem small, but getting gain right is a giant leap. I mean, a giant leap forward to creating a great mix. If you can get your gain structure right, it's a giant leap forward to a great mix. You too, you will enjoy what you are hearing, because it means that your output level indicator, that's the meter indicator on your output level, you see everything approaching green level, smooth level, clean level, and clear audio. So we must be able to know how to get our gain right. Just like you can see in this picture here, that if the guy got it right at green level. And with this gain structure, if you move ahead, we move to faders. You know, I told you that faders we are coming to that. But we have to fix the main one, which is gain. Fader slides. You can see the picture here. This is what we call faders. You can see my mouse moving on top. And I know everybody here is familiar with this. These are faders. These are faders. Input faders. So these are the volume control of an audio mixer. You can see now that gain is not the volume control. Faders slide. These are the volume control of an audio mixer. Either digital or analog mixer console. You find this fader on top. There are different types of fader slide control on a digital mixing console. We have the input faders, this. We have the bus faders, and we have the master output faders. Now, if you are very conservative with colors, you see that most of the time, our master output faders control, they are always in red color, either digital or analog. I've observed it. The master output faders are always the red one, this type. You can have the input as green, and no, not really green, black and white, yes. Then you have the buses, something like blue or green. Yes, that's what we call in the other something, we call them, what do we call it? Group, yes. On the analog, you see them as group. On digital, they are called buses. And when you see your group button, you see that it's either blue or brown. Do they use brown? Yes, blue or brown or green. But for your master output fader, they are always in red button. You see them in color red. The master output unity gain fader is set to be 0 dB level. This is the softest sound that is audible to human being. It means that what we are trying to explain is your master output fader should always be at the unity gain of 0 dB. When you look at your audio mixer, the way it is set, this fader, you have then the unity gain is 0, you have plus 310, then you have the minus all the way down. The faders have to be on unity gain 0. And to make things easier, you see it like a box. On each channel, they write like a box where it will sit. I can see that design in all mixers. At that unit gain, you see that where they write like they do a professional mixer, you see a box where that fader will sit inside. And once it sits inside, that's the unity gain where it's sitting in. Now, we have to move to the nature and the characteristics of a sound wave. You need to understand this so that you know what you are dealing with. If you don't understand the definition of a sound wave, then you don't know what you are dealing with, because that's what we deal with as audio engineers. We deal with sound waves. A sound is caused by a vibration object, provided it has a medium to travel. Provided it has a medium to travel. True, without vibration, there can be no sound. If the medium of travel is without vibration, without that medium vibrating, there can be no sound. Sound wave consists of disturbance moving out from a source of surrounding place, with the result that energy is transferred from one place to another. You can see from the picture here that we have a speaker where my mouse is pointed to. We have a speaker and we have our hair. That's the hearing, human hearing. You can see that there's a movement, a vibration coming from this speaker into it. If there's no vibration to move in, we can't hear anything. So you can see the wave in which the medium, the vibration is moving. That's the medium that is carrying it, which is the air. Sound wave consists of disturbance movement out from a source of surrounding places, with the result that energy is transferred from one place to another. Now, here is the thing. All audio works is about manipulating sound waves. If you can get that sink into your head, that you are just manipulating sound wave, the end result of your work is the series of high and low pressure zone. That's why it is most important to understand how they work. They are the raw materials of our art. They are the raw materials of our art. They are the raw materials that we are working with, or that we needed to work with. And what is a sound signal? We have just talked about sound wave as our material. But what is sound signal? It's different. Sound signals, when you are making a recording as an audio engineer, you deal with three types of signals. One, sound wave. That's acoustic. You can see the one we talk about. Two, analog signal. That's the electrical voltage. And three, numerical value, which is the digital. To produce sound, objects vibrate against the air molecule, which pick up the vibration and then passes it along as sound wave. When these vibrations strike our ear, we hear sound. And sound travels out from the source of speed of 240 meters, that's 1,130 feet per second for dry air at 20 degrees centigrade at sea level. Number one, sound wave and the acoustic. And the medium at which you are propagating your sound wave as an engineer is very important. You know, we have acoustic engineers as sound engineers too. Just like we have different areas like the front of house FOH engineers, we have the stage monitor engineers, we have the riggers, those that rig audio sound, we have recordists, those are the recording engineers, and we have acoustic engineers. It's only in Nigeria here that I find that everybody is doing everything together. If you want to read, if you want to do the mixing, you also be the one to record. We do everything here in Nigeria. But they are specialized area. Even we have recordists. Most of those recordists are also working for broadcast audio engineers. Most of the events you see people setting up. Like, let me use the experience for an example. Then you see a big setup. You have departments. You have the riggers. You have the front of house engineers, they are in the congregation, in the midst where people are. And you have stage monitor engineers, they are in the backstage with the musician and all the singers. You have the broadcast engineer, they have their own mixer separated from those areas. They are inside maybe an OB van or something that they are recording their own. And they send it to live streaming like YouTube or all those things. So your acoustic in which you are propagating your audio, you must be very knowledgeable about it. There are some halls that you enter to that you hear echo. Let me tell you that if you want to set up beside a sea, maybe like Oniru Beach, for example, with your PA system, the type of equipment you will read there will be different from when you are setting somewhere at Abiola Park in Ojota. Why? Because the atmosphere at the sea level at Oniru Beach is different from the atmosphere at Ojota. Mind you, the atmosphere at Ojota environment is also different from when you go to KICC Dome. So you must understand your medium of propagation, where you want to treat your sound. So it's very important that you understand the medium in which you are propagating your sound wave. Acoustic, you cannot overemphasize it. You cannot overemphasize it. There are some all you will get into that when you clap your hand, you will hear a vibration. My God, if you want to set for that all, you have to be technically inclined to know the type of equipment you place. If not, it will spoil the show. So those are the acoustic area. Now, the analog signal, they are the electrical voltage. I'm trying to lay emphasis on this. They are the electrical voltage that is coming from our microphone into our mixer. The electrical voltage is also coming from your guitar into the mixer. Electrical voltage is also coming in from your bass guitar, from your keyboard into your mixer. How do you manage these analog signals? You manage it by your electrical voltage. So that they go. Most of the time, you see that we use ZI box. What is ZI box? I don't want to go into ZI box. It's just to do some impedance matching to allow your electrical voltage to match with your audio mixer inputs. You know, you are sending a signal. So you see people using DI box for keyboard, DI box for guitar, DI box for what's it called? For other instruments like bass guitar. These are just to help their electrical signal so that they'll be able to get a good manage it well. I don't think I do installation or do a sound where I don't put DI box on all my instruments, because they are the one that will help me to convert my electric signal to the input source of my audio mixer, whether digital or analog. So the numerical value are the outputs that you are sending and you are capturing to record on your laptop. Some you grab with some another device, both video and audio. Maybe you are into broadcast, you send it to your YouTube, you send your audio along also to the media, they grab it, they save it, they record it. Some send it to YouTube where you can watch later. Some stream to Facebook where you can also watch later, Instagram, and all other platforms. So those are the numerical value. They are the outputs and they are digital. Why are they digital? Because you can see them in a numerical value. You cannot say that this is what, and then when you see the sound wave, you know that they are numerical value that you cannot read. They are digital value. They are digital value. So I will want to move forward a bit. Noise. Every engineer don't like this word, but they are always with us. They want to stay with us. They want to live with us. They want to die with us. But they are something that we don't want. They are just the opposite of sound. Noise. There are two types of sound in recording. A, Sound of a definite pitch with musicians call a note. B. Sound without definite pitch called noise. Noise is an integral part of any program material. The difference between a sound and a noise is very obvious to the ear. Because sound consists of regular vibration, but a noise consists of irregular vibration, unwanted, which may be defined as unwanted signal in any program material. Let me pause here. I know a lot of us, we have run our cables, connect our microphones, connect our keyboard, connect our broadcast, Zoom, everything, and you'll be hearing some noise, some electrical noise, either coming from our cable connection or one of our cables has crossed the power cable. You have those unwanted noise. You will hear it with your headphone and you'll be wondering where is this noise coming from. Or probably from your guitar or your bass guitar or your combo, even from the mic. You keep on hearing this noise. You'll be wondering as an engineer, where is this noise coming from? Where is this noise coming from? This unwanted sound, where is it actually coming from? And before you know it, it's something that you don't really like because you will know that it's a noise. Some come with ease, some come with pop. It can be in any form. A sound engineer is mainly concerned with two types of noise in recording process. That's in our production. System noise that are introduced by electronics equipment. Do you know that some of our audio mixer too, they introduce noise, they're analog. That is why digital has come a long way to clear all those. Because most of our capacitor and something inside, they generate some noise, electrical noise in analog. Then B, we have ambient noise that are introduced by acoustic environment. Just like you are in a place and you see some people making noise or car passing around you. Maybe you want to record outside and you are hearing the voice of a breeze blow into your microphone, all those acoustic around environment noise. Or you are hearing some people just playing around of children around your microphone, outside. Those noise are all environmental noise. Or you see fan. This one is very common in church when pastor is preaching. You see fan blowing into pastor microphone. Or maybe the person that is leading worship, just see that side, you come like you hear the noise, the environment noise, the fan noise coming into your microphone. This can be dealt with by understanding the concept of signal to noise ratio.